Section 4.3.5. Analyze the residual plots below and identify which, if any, of the conditions for an adequate linear model is not met. So, if we take a look at the graphs here, here's our first one, here's our second one, and we'll discuss why this is none and this is a constant error variance. Now, residuals play an important role in determining the adequacy of the linear model. Residuals are analyzed to determine whether a linear model is appropriate to describe the relation between the explanatory and response variables, to determine whether the variance of the residuals is constant, and to check for outliers. To determine if a linear model is appropriate, a residual plot is used, which is a scatter diagram with the residuals on the vertical axis and the explanatory variable on the horizontal axis. If a plot of the residuals against the explanatory variable shows a discernible pattern, such as a curve, then the explanatory and response variable may not be linearly related. The given plot here to the left does not show any discernible pattern. Now, if a plot of the residuals against the explanatory variable shows the spread of the residuals increasing or decreasing as the explanatory variable increases, then a strict requirement of the linear model is violated. This requirement is called constant error variance. If you look at the one on the right, you can see it's increasing here on the right and then decreasing here on the right as well. So that would be considered a constant error variance. Now, the spread of residuals does not change as the explanatory variable increases in this given plot over here. So recall that outliers are extreme observations. An outlier can also be thought of as an observation that does not fit the overall pattern of the data. The outliers can be found in a residual plot because the residual will lie far from the rest of the plot. If you look at both of these plots, okay, there are no outliers in this residual plot because no residuals lie far from the rest of the plot. Thus, the one on the left, all the conditions are adequately linear met. So let's go ahead and highlight that so we can see that this last statement represents the first graph. And then if we take a look at if a plot residuals show that there is an increasing or decreasing, then we say that this requirement is called a constant error variance. And you can see it's increasing and decreasing here. So therefore that graph would represent the constant error variance.